Okay, so there's this solubility chart that I'll give you on the test. So I'll give you this solubility chart, just be able to use it. And some examples. Do you remember how to use this? Alright, so BR is right here. So this is telling you everything that has BR in it is soluble except for these. So is this one soluble? Yes, that one is soluble. What about NaOH? We've got OH down here. This is telling you anything with OH in it is insoluble except for these. So that one is soluble. Because NaOH is in the exceptions, and in the bottom part here, the exceptions are things that are soluble. MgSO4. Sulfate is right here, SO4. So everything with sulfate is soluble except for these. And what is that? Mg. And Mg is not in the exception, so that's soluble as well. K2SO4. Skip B. So K2SO4. So anything SO4 is soluble. These are the exceptions. None of these have had exceptions. There's the CO3 down here. So everything CO3 is insoluble except for these. So those are all soluble. There are more of those in the quiz. Our quiz. Quizzes. Test 2 practice quizzes and solubility too. Hg2Br2, is that soluble? Question?
Before I forget, can you up the things that you don't have quizzes for?
Yeah, that's probably what we should spend our time on. Anybody want to do more solubility? Let's. something like this. You'd be asked for the products. There's also the complete ionic equation and the net ionic equation. This is the molecular equation. So what do you do to figure out what the products are here? You've got Li plus, I minus here, and you've got Ba2 plus and S2 minus there. So those charges, that just goes back to test 1. Now we're going to put this positive one with that negative one. We've got Li plus and S2 minus. And then these two, Ba and I. But I'm not done. I have to make a formula out of those. There's 2 negative charges and 1 positive charge. So that means I'm going to need 2 of those. So one of the things I'm going to get is Li2S. And I'm going to need 2 I's to match the 2 plus here. So I'm going to have Ba(I2). That makes sense, right? So far? You guys good with that so far?
Yes.
The rest is balancing. I've got 2 Li's over here and 2 I's over here. So I need to do that. So now I've got 2 Li's and 2 I's. And that balances it. You guys okay with that? All right. Do you remember how to do the, oh, one more thing. This is asking you, does this reaction occur? Or do you get a precipitation reaction? Do you remember what you have to look for? Yeah, you need to look at the solubility chart. AQ means it's soluble. And Li is soluble. BAS is soluble. And now we have to ask the question about these. Is lithium sulfide soluble? So there's the sulfide one. It says everything sulfide is insoluble except for these. Lithium is in the exceptions. So that's soluble. Iodide is up here. Everything iodide is soluble except for these, except for silver, Hg2, and Pb. So is that one soluble?
Yes.
So there's no precipitate, so what you say for that one is no reaction. That was number 51. You want to do more of these? Let's see. Yeah, let's do that. This is telling us that that one's soluble. This is actually what the other questions are set up. So it's telling us that at least those 2 are soluble in the setup. All right, so what are my products going to be? First of all, what's the charge on chromium? you've got Br, which you've got two of them, so you've got two negative charges. So this is 2 plus. CO3 is in that chart of polyatomic ions, but sodium is a +1 and there's 2 of them, so that tells you that this will be 2 plus. The CO3 is going to be a 2 plus polyatomic ion. So we're going to put this plus, no, 2 minus, sorry, that's 2 minus. All right, so yeah, now this goes there. We're going to make chromium carbonate. They're both 2 charges, magnitude 2 charges. So the +2 and the -2 cancel out, so that's correct. And then we're going to make NaBr. And to balance this, since I've got 2 Brs here, 2 NAs, I need to put a 2 here. Now it's balanced. This is soluble if you go by the chart, but you'll find out that the carbonate is not soluble by looking at the chart. The chart says carbonate is down here, so right here it's saying that everything carbonate is insoluble except for these. And chromium is not in the exceptions, so chromium carbonate, that's going to be, put an S here to indicate that it's a solid. So this one, we do get a reaction. Okay, so the complete ionic equation is Cr2 plus aqueous plus 2 Br minus aqueous plus 2 Na plus aqueous plus CO3 minus aqueous 2 Na aqueous plus 2 Br minus aqueous. Since this is a solid, we just bring it down as is. And that's the complete ionic equation. Remember that? Follow that? Any questions there? And then the net ionic equation. You cancel out everything that's the same on both sides, and that's going to be those. So your net ionic equation, you just bring this down and this down. Cr2 plus aqueous plus CO3 minus aqueous makes Cr solid. And that's the net. Complete ionic equation. This is the net. And this is just called the molecular. Do you remember what these are called? Mark it up. Just a vocabulary word. No. That's from the gas reaction. We'll get there. Those are the spectator ions. They're just spectators because this is really what we're focused on. We also want to remember what we do here? Sort of the hallmark of a strong acid and a strong base when they react. Huh?
Oh, you have water and you have salt.
So these two things and these two OHs are going to make two H2O. So we've got an H, an H, and an OH, and an OH. So that'll make it H2O, and that'll make an H2O. Two H's and an O. So there's my two water molecules. And then I'm going to get calcium sulfate. That's the one that's partially soluble. I'll count that either way. One of those charts says it's insoluble, the other one says partially soluble. And we just put an L here to say that that's liquid water. And there's your acid base. And it's even balanced. If you wanted, you can do complete and net ionic equations. The net for this is going to be I think if I ask you for net ionic equations, I'll just do it for the precipitation reaction.
So for acid base, the main thing is water.
Yeah, you're going to find water and then another quantity.
Yes. Okay. So always just try to get water out of each. Okay.
Yeah, I guess your first thought should be, okay, water. That's going to be one of the products. Okay, the gas evolution reactions. Look in here. Bases. There's only these four things. There's the intermediates that you find out. Intermediate breaks down into two things. Breaks down into water and CO2. So it's these. Just write it down. So these are in that PowerPoint that I'll give you.
Is every chart that's in the PowerPoint something we'll have on the test?
Yeah, everything's in this PowerPoint. I'll let you have for the test. That. Four of these. So that's what's in that chart. These are the gases that bubble up out of the liquid. They also need water. You should be over there because that doesn't break down further. And the types of problems you'll see sulfide. Those will react. This acid. So the acid attacks this. It's not that this dissolves. It gets attacked by the acid. So all of these acid plus something produces these. Okay, HBr and IS. So we're going to make
So is this the whole equation to be given or just HBr?
yeah, this is what you'll be given. And then you have to figure that part out. And you're still going H plus Br minus. There's Ni in there S. What's the charge on S? It's 2 minus. So that means that nickel is 2 plus. So we're going to put the pluses with the minuses. So I'm going to need 2 of these. I'm going to need H2S because that's -2. And I'm going to need NiBr2. You follow that? So you predict the products. And yeah, you're going to need a 2 there. There's 2 H's and 2 Brs. But the key to look for here is this. You notice that's going to be a gas. I think that's it. But there's your gas that's produced.
Now we know that it's a gas
Because it's in this list.
oh,
Here's a gas. This one doesn't break down any further. I'll do another example. Here's the gas. Here's the gas. Gas evolution reactions. Let me do a different one of these. So the H2S just shows up and you're going to put gas by it. Let's do a different one though. CO. So here you're doing the acid. Okay. I'm giving you the polyatomic ions chart again, but this is what you'd be given, and you're told to predict the products of the reaction. H plus, a Cl minus, a K plus, an HCO3 minus is in that polyatomic ions chart. So H comes to this, and we're going to have H2CO3. We've got a positive and a negative, so that's fine the way it is. And then we're going to have KCl. HCl. And then what you need to recognize from there is, oh, there's one of those, H2CO3. So you're going to replace this with this. So this just spontaneously breaks down and becomes the H2O plus the CO2 gas. That's a liquid. So that's actually the products here. Is it balanced? Yeah, it's balanced. 2 HCO2. That's how that works. You're just recognizing one of these as a product, and then you go, oh, okay, that breaks down into these two things. So I've replaced this with these two things. Gas evolution. You guys okay with that? There's a few more there to practice in the book. Just email me if you're looking at it and you're confused. What else we got? Redox. Let's see. Yep, redox. What I gave you guys for that is just a big PowerPoint. But we can go through these. Also note that in this PowerPoint is how to decide what the oxidation state is. I think this makes it sound a lot more confusing than it really is. This other one is the one I got from another book, but I think is a little more straightforward. But pretty much, if there's oxygen there, you key in on that and assume it's -2, which would be its charge anyway. And everything just flows from there. We should look at these in the book. Okay, looking at 7-5 here. What's the oxidation state of silver there, Ag? You just go by the charge that's on it, which is 0, so its oxidation state is 0. Remember that. If Ag is not charged, it's going to be a solid. Oxidation state for Ag here. It's just the charge is +1. So these mostly break down into exactly what you expect. The oxidation state is its charge from the periodic table, or its charge. If it's an ionic compound, it's just going to be the charges that you're already familiar with. So CO3 is actually a covalent compound. All of these in this list, this first slide, the polyatomic ions, all of those are actually little molecules. They're not ionic compounds. It's just that those little molecules are charged, and then they will get involved in an ionic compound. But if you look at all these in the book here, for 75E, if you assume that oxygen is -2, and there's 3 of them there, so it's yeah, let me do this. To look familiar to that PowerPoint that I've got uploaded. So what's the oxidation state of carbon? What's the oxidation state of oxygen? There's 3 oxygens, so I got a total of -6. What goes on the other side of this equal sign is this charge, -2. So what needs to go here? This would have to be +4 to equal -2. So So carbon is +4 and oxygen is -2 here.
So does that mean oxygen has gained 2 electrons? Or
Yes.
Oh,
Well, I would say it's a lot. You don't talk about gaining or losing until you have the chemical equation, the reaction to look at, which is what we got to do next. Question?
Yes, I just moved, so for E, we would write what would be the definitive answer.
Well, it asks up here, assign oxidation states to each atom in the element, ion, or compound. So the answer is carbon +4, oxygen -2. Let's get down to the reactions. These reactions are saying, it says, first tell me whether or not this is a redox reaction. Truthfully, I'm not going to ask you that. I'm going to give you something that is a redox reaction and ask you about what's being oxidized and what's being reduced. But let me do that from this PowerPoint. So we've got a bunch of reactions in there that are so this is up on D2L, this PowerPoint. And it's these reactions on this page that you can practice with. I've gotten an outline of it on all the green slides. Let's pick one of these. So let's say you're given this. E2O3. CO2 is a gas. This is a solid. This is gas. So to figure out what's being oxidized and what's being reduced, you have to figure out the oxidation numbers for everything here, the oxidation state / the oxidation number. If oxygen is 2 negative, there's a total of -6 there. There's no charge up here, so I'm going to say equals 0. So what needs to go here? I have 2 FEs. And I got to split that 6 up among them, so what's the charge on Fe here?
plus 3.
That's 3 plus. And there, we figured it out. Oxygen was 2. Let's say -2 for oxygen and +3 for iron. Now we go here. If oxygen is 2 negative, then the carbon has to be +2. You with me there? Oxidation state on carbon. What's the oxidation state on this iron? It's 0. If it's a solid, just a solid metal, then it's 0. Here we've got 2 carbons. There's a -4. There's no charge up here, so it equals 0. So what has to go here? +4, and there's only that one carbon. So the carbon is +4, and the oxygen is -2.
Okay. So if there's like a 3 in front of the, do we
This actually doesn't mean anything for these. Those coefficients don't mean anything. If you do more redox in 1212, it'll come up, because then we start figuring out how to balance these. And you can only do that by tracking how many electrons are moving around. But, so we go from a +3 down to a 0 for the iron. So it goes from higher to lower. Its charge is reduced. Therefore, we can say iron is the thing being reduced. We can also say it's the oxidizing agent. You remember that? And then oxygen here, and oxygen there are all -2. So oxygen doesn't gain or lose electrons through this reaction. The carbon goes from +2 up to +4. So that's being oxidized. So reduced is gaining electrons. Oxidized is losing electrons. And we can also say that iron is the oxidizing agent and carbon is the reducing agent. That's the redox process.
How do I write that out? Like, how would the answer be written?
Sorry?
How would the answer be written out?
Well, it'll be A, B, C, D, E, and it'll say,
Oh, what's the,
and one of them will say, one of them will have the will correctly say that iron is being reduced,
yeah.
carbon is being oxidized. And I'll say it backwards as a trick answer, and then I can involve words like reducing agent and oxidizing agent. What else we got? I think that's everything that we don't have quizzes for. Solubility restarted. So the quizzes are test 2 practice quizzes. Anything that says test 1 you can ignore. You want to go over some of these? What about molecular study?
Yes. And then are we doing the quiz on Friday?
Yeah, I think instead of doing it on Wednesday, on the same day, let's do it Friday. That makeup quiz thing, let's do that Friday instead of Wednesday, so it's not all on the same day.
So does this exam not include specific about here?
Yeah. Specific heat, what's the other thing I started on?
Enthalpy?
Enthalpy, yeah. We'll just do that on test 3. Test 3.
Okay, so that's not going to be on.
Yeah. I just wrote that on there. Not on test 2. Specific heat, enthalpy, I'll just do on test 3. Yeah, we'll have a day in between to try to do some review. Ideally we have several days to review for the final.
What is the SC?
I don't remember, I think I figured out. No, I guess I didn't. So the way I have this set now, we will have a couple of days to review, so that'll be good. I think ours is on. I don't know. I'll have to look it up. Anybody look that up yet? Okay, looking at the quiz, whoever's watching the video can't see it. Watching the video, go to the quizzes. Go to the quizzes if you're watching the video. Go to molecular shape, aka molecular geometry. You guys know the answer to this first one?
The second one?
Yeah. It's the second one. Do y'all see that? Trigonopyramidal is ultimately still tetrahedral. It's just, you guys remember this stuff? No? I have like model. Regular shapes. Okay, starting with carbon. So picture the purple thing here being carbon. Should I try to move the camera? So I always give you a Lewis structure to look at, and then you can tell me what the shapes are and the angles. So that's good enough for somebody watching the camera. All right, so the purple thing is carbon. Carbon makes 4 bonds. The white things around it are all atoms. We call this shape tetrahedral. And the angle associated with that shape is 109.5. All right, now, question?
How many different types of molecular shapes are there?
How many different vectors? All the ones that will be on the test, I'll go over here. So let's just say this is number 1. This is what carbon will do. It'll bond with 4 different atoms. And we say it's, by its electron domain geometry, it's tetrahedral. And then when we go, okay, then its molecular shape, it just defaults to tetrahedral. And if that's confusing, differentiate that with, this is what nitrogen will do. Nitrogen will make 3 bonds, but it's still got that pair of electrons. So this shape is still ultimately tetrahedral. So that's why this says by electron geometry, it's tetrahedral. There's a pair of electrons there, and there's electrons in these sticks too, because that's the bond that has the pair of electrons. So it is tetrahedral, but can you see the trigonal pyramid? The purple thing is the apex, and that would be nitrogen in this case. Okay. All right, now contrast that, go one more over and do oxygen. This is what oxygen would look like. It is ultimately tetrahedral, but the shape we call it is bent. So those those three things that I just went over are all bond angle of 109.5. Because by electron geometry, they're tetrahedral. Tetrahedrals. Bond. So that is two things. Let's go back to carbon. Another way you might see carbon is like this. You remember this shape? Actually says it. So trigonal planar, there's no pairs of electrons to ignore. So the molecular geometry is trigonal planar. So there's another one, trigonal planar. And you remember the bond angles? You could just memorize it. I'm not going to give you a chart. You could just memorize them, or you could use some reasoning and say if there's three things around it, and it's 360 degrees, then it's got to be 120 each. You guys okay with that? Yeah, I'm not going to give you those charts, so you have to know those. What else do I want to do? All right. This is still carbon making 4 bonds, but it's making a double bond in one direction and a double bond in the other direction. It's linear, there's no pairs of electrons to ignore, so the molecular geometry is linear, and the bond angle is 180. Alright, let's go back to nitrogen. So nitrogen can do this. It can also have a double bond. So there you have 3 bonds, double bond on one side and a single bond on another side. So nitrogen makes 3 bonds. If nitrogen is in this shape, it is, you do see the trigonal planar shape there. If you think of that pair of electrons being an actual thing. But if you ignore that pair of electrons, you just have a bench. But the angle comes from this trigonal planar. So what's the angle? We're talking about this angle here. Also, so this one's bent to 120 degrees. Let's go to this one already. I feel like I already did that. Okay, but I guess I didn't say the bonding. So you can see that this is tetrahedral, but if you ignore those pairs of electrons, then you would just say bent. But this one is bent at the tetrahedral angle. So the angle between these bonds is 109.5. Alright, so 4 things around it, 3 things around it, 2 things around it. So we've done tetrahedral, but if you had 5 things around it, you get this weird thing where there's different positions. You have the equatorial position, these 3 here, and you have the axial positions going up and down. You remember what we call this? Given a trigonal bipyramidal. So that one we would call trigonal bipyramidal. If one of those things around it was a pair of electrons, this is the shape we call seesaw. See it? Seesaw. It seems like the book skipped this one. But could you guess what it said? Because that's just called C shape. So you have 5 things around it, and 2 of those things are pairs of electrons. You get C shape. Did your book do that? I meant to just leave them all with the book. I know your book didn't do this. That actually just reverts back to linear. It is trigonal bipyramidal. You get linear bond angles. 6 things around it. things around it, and all of them are atoms. Do you remember this one? It's octahedral.
Did we talk about octahedral?
Yep, we did. So this is the last category of shapes, octahedral. The bond angles are all 90 degrees. Y'all remember this one?
What was for the, what's the angle
I
for the
kind
trigonometric?
of skipped that. This is the only one that's weird. It's got several different angles. You've got this angle that's linear. You've got these angles that are 120 degrees. And you've got this angle that's 90 degrees. But I'll probably just want to skip those. Alright, so back to octahedral. Alright, so octahedral, if you have 6 things around it and all of them are atoms, then you have octahedral. But we have that. I can't remember which of these your book do square parameters. It seems like it's skipping that. But you can see why we would call that one square parameter.
We're skipping that one?
Fine. Yeah, I don't think the book did that. 5 basic shapes. Well, there was a chart here. There's a summary chart. This. So it's got. So you were making a list. This is table 5.5. No, these I want y'all to know. Tell her that it's table 5. It's table 5.5.
Table 5.
So we've got linear, trigonal, planar, bent, tetrahedral, trigonal, pyramidal, bent, trigonal, bipyramidal, seesaw. Oh, they do have T-shaped. Seesaw, T-shaped, and linear. And then those last few. Octahedral, square pyramidal, square planar. So, octahedral, there's octahedral. If one of those is repaired with a pair of electrons, replaced with a pair of electrons, if you ignore that pair of electrons down there, can you see why that would be square pyramidal? And then one more pair of electrons. The pairs of electrons oppose each other, and you get square planar. So 6 things around it, 4 of them are atoms, and 2 of them are pairs of electrons. And again, look at table 5.5. It's got all of them. Okay, so that's where the new. So the answer to this one, trigonal pyramidal, is 109.5 degrees, not 120. All right, and I'll remind you guys, I'll go to question number 2 for molecular geometry here. I'll remind you that when we draw molecules like this, we don't draw them to indicate any sort of shape. So when you see this oxygen here, you see it should have 2 pairs of electrons on there, but we don't always put those on there. But here's oxygen bonded to 2 different things. What is this? It's a molecular shape. Don't be fooled by what you're seeing. Okay, well, hold on. Oxygen. This is what oxygen looks like bonded to two different things. Bent, and what's the bond angle? So when you look at this, don't be fooled. This oxygen is bent in front of the shape is an issue. The same with this oxygen. What about the carbon? You get fooled by looking at the shape. So carbon making a double bond in one direction, a single bond in another direction, a single bond in another direction. That's what carbon looks like. The way I told you to think of it is as a way to help you memorize. You might see carbon bonded to 4 different things. You might see carbon bonded to 3 different things, but still 4 bonds. Just one of them's a double bond. 4 bonds, 4 bonds. You might see carbon like that, and you might see carbon like that. That's the 4 different ways you'll see carbon. Remember this? Nitrogen has a pair. You might see it bonded to 3 different things. You might see it bonded to 2 different things. That's all you have to worry about with this. Nitrogen can do this, but that's not going to show up in this discussion. That's like a null case. Oxygen, it can be bonded to 2 different things, and that's it. If oxygen is doing this, you're back to that null case, where there's only 2 atoms, so it's going to be linear, I guess, but you won't be able to. All right, so what is this shape? Huh? 4 different things around it. Tetrahedral. Well, let's do this one first. It's got 4 things around it. So its electron geometry is tetrahedral, but you ignore that pair of electrons that you get. So its molecular shape is trigonal pyramidal. This one is also, so the bond angles are 109.5 because the bond angles come from the fact that there's 4 things around it. This has 4 things around it as well, so this bond angle is 109.5, but we call that bend. With me. This is trigonal planar. So you got your triangle there. No pairs of electrons to it. This is trigonal planar, but you ignore that pair of electrons, you get a bent shape. But this one's bent at 120 degrees. This one's bent at 109.5 degrees. You with me? And that one's linear and that one's linear. So this is bent at 120 degrees. This is trigonal planar at 120 degrees. This is tetrahedral at 109.5 degrees. This is trigonal pyramidal at 109.5 degrees, and this is bent at 109.5 degrees. So those are the 4 ways you might see carbon. These are the 2 ways you might see nitrogen. This is the only way you'll see oxygen. It might be in a molecule. You might have that in the molecule you're looking at, and you might have this in a molecule you're looking at, but you won't be asked the molecular shape for those, because those are just like, I don't know how else to put it, they're just null cases, because there's only two atoms connected to each other, so if you're going to say anything, I guess you'd say linear. But these are linear because they're connected to two different things, but they still happen to be straight across. And then below carbon, silicon would be in this situation. Below nitrogen, phosphorus can get in this situation. Below oxygen, sulfur can get into this situation. And then there's the ones that have 5 and 6 on them. That's how I told you. So question 5, look at this sulfur atom. What's its molecular shape and what's the bond angle? Yeah, 109.5. This carbon is connected to 4 different things. Tetrahedral, the bond angle. No, it's tetrahedral, so it's 109.5. You get fooled by the shape. Now look at this nice linear-looking carbon. What's the shape? I mean, oxygen. What's the shape around this oxygen? It's very linear-looking. But it's not linear. It's bent. And what's the angle? Yes. How about this nitrogen? That's nitrogen with a double bond one way, a single bond another way, and a pair of electrons. It's bent. And what's the angle? That one's not tetrahedral. It's this one. Yes. What's duplicate? Oh, it's just asking about different atoms. All right, this has how many things around this pie right here? Yeah, there is a pair here, so there are 5 things around it. So this is question 14, the first one. I'm not even looking at what it's asking, but let's go through this. Okay, so this first one, it's got 5 things around it. One of those things is a pair of electrons. 5 things around it. One of those things is a pair of electrons. So this one's seesaw. This one has 6 things around it. One of them is a pair of electrons. Remember what that does? 6 things around it. One of them is a pair of electrons. That's square root. This one has 6 things around it. 2 of them are pairs of electrons. And that's this one, square root. 6 things around it, none of them are pairs of electrons. It's octahedral. That's this entry. 6 things around it, all of them are atoms, 0 of them are pairs of electrons. Now if I did this, one of them is a pair of electrons. This is what we call square perimeter. And that's why this says 5 things, one of them is a pair of electrons, square perimeter. See that? And then this next one does this. The pairs of electrons oppose each other. You get square perimeter. Here's 6 things around it. None of them are pairs. So this one's just octahedral. Make sense? What else? Electron configurations? No?
Because we'll have,
Do you want to go over? What's the first thing you do for electron configuration?
Upside down here.
Yeah, the way I teach this, this is asking for aluminum. Periodic table. So you find aluminum, and since it's asking for neutral aluminum, it's going to be 13 electrons. So the magic number is 13. Go back to the quiz. If I want the electron configuration, this quiz says ground state. That's what we need. The ground state electron configuration. And we're doing aluminum here. Magic number was what, 13? The first thing you do is you go 1, 1, 3, 1, 3, 5. 1, 1, 3, 1, 3. Inverted Christmas tree. And then you have to remember this game. The single ones are S's. The triple ones are P's. And the one that has 5 are D's, D orbitals. And their numbers. For the S's, this is 1, 2, 3. The first P's are in level 2. So these are 2P, 2P, 2P. These are 3P. Yeah, there is a 4S right here, but you start going by the periodic table if you're going to go bigger than that. But the 1, 1, 3, 1, 3, 5 is just to get this on here. So these are 3D. And if you follow the periodic table, you'll see that 4P is what comes next. But if we're doing 13, follow the rules. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's it. That's one way to represent the electron configuration of aluminum. Another way is to go 1s, 2 electrons, 2s, 2 electrons. 2p has 6 in it, 3s has 2 in it, and 3p has 1 in it. There's another way to represent the electron configuration of aluminum. And then the next way, we have periodic tables up in here now. When that happened, we would do neon. We would just turn this into, we turn all of this into neon. Because that is the electronic configuration of neon. And then we can go 3s2 there. There's another way to represent. So now I've shown you 3 different ways to represent the electronic configuration. Wasn't there a 4th way? I don't think so. So I think y'all can do those. That's really kind of all there is to that. Oh yeah, the boxes. fourth way, with what seemed to like, is 1s, 2s, 2p, 3s, 3p, and you're just following the same game. 2 electrons up and down. 1, 2, 3, up and down. So there's another way to represent the same thing. Chocolate configuration. Anything else you want to cover? Anybody? All right, I still have to write this test. That's what we will do Wednesday, and we'll do that make-up points quiz on Friday. I think what I'll do is just make a video of me going over them, and then between now and Wednesday, we'll just focus on the test. And at some point, when you're done with the test, you can look at that video.
Okay, and then we're doing a last question.
Yeah. Starting with question 30, although we skipped 26, 29, and 30. Skip the ones we skipped. And there'll be a subset for those. Certainly. Yeah.